Okay.
It's otherwise known as antiderivative.
Derivatives, yeah.
Okay.
Okay.
For example, in the derivation, we learn this. I'll write it like that. Like in derivation, like in differentiation of x raised to the power n is n into x raised to the power n minus 1. Right. But in integrals, when you integrate x raised to the power n, you have to put this big S. This is the integral symbol. Okay. And you have to put dx here. So this mentions the variable with respect to which you are integrating. This dx means you are integrating the variable x. So you have to address it. So this is the symbol. You always have to put the big S, and then you have to write the f of x, the function, and then you have to write dx. In case if you are integrating with respect to y, you have to write dy.
dy.
In case if you are integrating with respect to z, you have to write it as dz. Understood? Okay. So integration of this x raised to the power n is x raised to the power n plus 1 whole divided by n plus 1. Okay. Here the power is getting decreased and the power is in multiplication. Here is just ulta. Like here the power is getting increased and we are performing division here. Understood?
Yeah, I understand.
Okay. So for example, assume you have a function as x square. You have a function which is x square, a parabola function. They're asking us to integrate it. First of all, integration means, what do you mean by integration in general? In English, what do you mean by integration?
In integration means putting together something. Putting
together something, exactly. So here you are integrating means you will join all the points, okay?
Wait, what is this exactly?
For example, in case you're having this shape, you are finding the area of the shape means you will divide the shape into pieces, like similar pieces, and then you will add everything.
Yeah.
This is similar to summation. Okay. Instead of performing addition, you can do integration.
Okay.
Like imagine you are having a square pieces, like you do have a like 20 pieces, and you know the area of one piece. Like imagine the area of one piece is like 5 meters square or something. So in integration, you put that. So there are 20 pieces totally. So you'll write the starting limit as 0 and the ending limit as 20, and then you will integrate it.
Okay.
You don't have to add this 20 times repeatedly. This is like multiplication only. You don't have to do the same operation again and again.
For 20 times.
Yeah. If you are able to divide the bigger unit into a smaller unit, the smaller unit should be similar. You have to divide the smaller unit into you have to divide them in the form of a same dimension. Okay. If you are able to find the area of a single piece, if you are able to find the area of this one, you will be able to find the area of the entire portion with help of an integration. Even if you have some irregular shapes also, you can change the irregular shapes into pieces, like again, like you can divide them into regular shapes. And then you can integrate them for finding the area. Finding the area is one application, okay? Finding the area of a shape is one of its application of the integrals. And you can also find the volume. Like you can convert from one shape to another shape also. That is also one application of an integration. You can rotate the 2D shape and you can convert them into a 3D, and then you can find the volume of the shape. For example, if you fold the rectangular page, you can create a cylinder, right? You are having a like rectangular sheet. If you join if you are joining this edge with this edge, you can fold them and you can create a cylinder. You can make a 3D shape out of a 2D shape. You're getting it. So that way, in case if you're rotating this constantly, Like imagine you're having a circle or something. Like if you keep on rotating, you can convert a 2D shape into a 3D shape.
3D.
Okay. So for that purpose also you can use integration.
Yeah.
Okay. So I'm just giving you some examples where do we use integration in real time. Okay. All right. So now we will do the x square. Like imagine we are having a function which is x square. You know how to draw an x square. X square means it will be a parabola which is opened upwards, right?
Okay.
So this parabola, just a second. So you have a parabola which is open upward. They're asking us to find the integration of it.
Okay.
Which means you are finding the entire function. Okay. So integration is nothing but you have to put a big S followed by the function, and then you have to mention with respect to which variable you are integrating, that also you need to mention. So the formula is x raised to the power n dx is equal to x raised to the power n plus 1 whole upon n plus 1, isn't it? So now the value of n is nothing but 2. Just compare your formula to your question. Okay, the base x stays the same, which is x. The value of n, the power n is nothing but 2, right? So just substitute them in the right hand side. So what's your right hand side formula? It's x raised to the power n plus 1 upon n plus 1. So it's going to be x raised to the power 2 plus 1 whole divided by 2 plus 1. So it will become x raised to the power 3 upon 3.
3. Yeah.
So that is your answer. We have done the integration, that's it. And you have to put c plus c. The c is nothing but integral constant.
Integral constant, correct. Okay.
Yes. This is integral constant, and this kind of integration is known as indefinite integrand. Indefinite means we are not sure about the starting point and ending point. We know this curve, but we are not sure where this curve starts and where it ends. We're not sure about the starting point and ending point. In the definite integral, we'll always mention the starting point as the lower limit over here and ending point as the upper limit over here. And then you will write the function followed by the address. So this is how you will write it. This is definite function. While solving a definite function, you don't have to mention the integral constant. Okay. When you solve an indefinite function, in case they didn't give you the starting point and ending point, means you have to include plus c in your final answer. Got it?
Okay. Yeah.
Okay. So let's do one more thing, like x cube. F of x equal to x cube. Again, like x cube dx means you just have to raise its power by 1. Again, write the power in the denominator and increase the value by 1. So it will be x raised to the power 4 upon 4 plus c. This will be your final answer. Understood, Shreynik?
Yes. Understood.
Okay. Okay, we'll solve some polynomial equation. Like imagine you are having a polynomial equation like this. Okay, so they're asking us to integrate this polynomial equation. Okay, so for integrating, you need to put the big S, f of x and dx. That is integral sign. Okay, so integral x raised to the power. I'm just copying the f of x. So this integration supports the distributive function. Okay, so you can distribute them into pieces like how we solved in the differentiation. Just you can distribute them individually, like just split each and every term.
Okay.
You're getting it, Shreynik?
Yeah.
So like this, you have to split it. So now, this also I've already told you. Here you are integrating with respect to x. You have a constant which is 1. Okay. Always rewrite the constant in the form of x. 1 is nothing but x raised to the power 0. Anything power 0 is known as 1, right? Here you are integrating with respect to x. So that is why I'm going to rewrite this as x raised to the power 0.
0.
Okay, so far clear? So
Yeah.
now you know how to solve this with help of this formula. X raised to the power n dx is nothing but x raised to the power n plus 1 whole divided by n plus 1. So x power 4 will become x raised to the power 5 by 5. And you don't have to put plus c each and every time. You can put it at last. You can put the plus c at last. Okay. And here you do have a minus sign. You put that also. And you have minus 3 into x cube. If you find the constant is in multiplication or division, take it out. Only if it is in multiplication or division. Okay. So just write 3 as it is. Integrate the x cube alone. Integrate the x cube alone. So integration of x cube is x raised to the power
4 by
4. Exactly. Good. Yeah. Again, you do have a constant which is in multiplication. You write that again. So x square will become x cube by x3. And you do have x here. X means it's x power 1, isn't it? So it will become x power 2 upon 2, and x power 0 will become x power 0 plus 1 upon 0 plus 1, which is x power 1 by 1. X power 1 can be written as x, simply, right? You don't have to put it like x power 1 by 1. It's just x. So that's it. We are done with the integration. At last, you just have to include the integral constant plus c. So this is your final answer.
Okay.
Understood?
Yeah, understood.
Okay. Please note it down. Please note it down one problem for your reference, because now it seems like you have understood everything. If you are referring it after a week, then it will be difficult.
Okay.
Please note it down.
I noted it. Noted it.
Okay. Now you will solve a question from your NCERT. Okay. I'll just give you a okay. You take the page number, what is it? Okay, it's 243. Okay.
Yeah.
243, you solve the question number. You solve the question number 1 itself. From 7.1, you solve 1 and 2, like subdivision 2. Subdivision 1 and subdivision 2 from the question 1.
Okay.
I'll just write the question in the book. Are you done with this problem? Shall I clear the window?
Yeah, clear.
Okay. So the question is x raised to the power 5 dx, that is subdivision 1, and subdivision 2 is 1 upon, it's x cube, right? It's not clear in the PDF. X cube dx. See, you just take the denominator to the numerator, change this fraction form into a real form, and then you do it.
One second. How, ma'am? How?
How? Like, what will happen if you take the x power 3 to the numerator? It will become x power minus 3. The sign, the power signs will change.
Okay.
Right?
X to the power minus 2 by minus 2, correct?
Yeah.
So we can leave it like that.
That's your answer. Like, just put plus c after that. It's x power minus 2 upon minus 2 plus c. That's it.
Okay. 1 by root y dy.
1 by root y dy. Okay.
Okay, minus.
How can you rewrite root y? In
Y
terms
to the
of
power
power.
minus. Y to the power minus
1. 1 by 2. Y to the power minus 1 by 2, right? What is root? What do you mean by root x? Root x means x power 1 by 2, right? X power half.
Y to the power minus 1 by 2. Correct.
So first rewrite them in the form of y power 1 by 2, and then you take it to the numerator. It will become y power minus 1 by 2. And then you perform integration.
Y to the power 1 by 2 by n plus y to the power 1 by 2 by 1 by 2.
Y to the power
Which
1
can
by
also
2 upon 1 by 2, which can also be written as 2 times of y power 1 by 2.
Oh yeah, 2 times of y plus c.
Yeah.
Wait, how can it be written as 2 power? Oh, okay. When you go add
Denominator
it,
to the denominator can be written as
yeah,
numerator.
correct. Okay, first subdivision finished. Second one.
No, this is fine. You can stop here. We'll move to the next concept.
That's
You are
another
this one,
concept,
right?
Yeah.
Okay. Okay. So this you did it. I'll give you an interesting one. Like you can solve x power 2 as x power minus 2 dx. Okay. We are allowed to
1
do
by
this. But
yeah,
in case if you're having 1 upon x dx, you cannot write this as x power minus 1 dx. We are not allowed to do this. Okay, I'll tell you why.
okay.
If you integrate this, what will happen? It will become x power minus 1 plus 1 upon minus 1 plus 1. So it will be x power 0 upon 0. So which is in the form of indefinite. You are getting 0 in the denominator. You cannot define this. Understood? So you cannot take this x to the numerator. Remember this. So there is a logarithmic form for this. Integration of 1 upon x with respect to x is nothing but log of x plus c.
How long? I don't understand this. Can you teach once
And
again?
x
Like,
cannot be 0. This is the formula. This is the formula. Because I
okay.
just told you why you cannot take the x into the numerator. Because if you take it, you'll be getting the answer in the form of indefinite. So that is why logarithm comes. So you will write 1 by x dx as log of determinant of x plus c. And because x cannot be 0. This is applicable to all kind of variable. Even if you're having like 1 upon y dy, you will write your answer as log of y plus c. And y is not equal to 0. Otherwise, we will be ended up having 0 by 0 form, which is indefinite.
Oh. Okay. Yeah.
Okay. The next formula, integral a power x dx is a power x upon log a plus c. And the a should be greater than 0, which means it should be greater than 0 and it should be greater than 1.
Why log a power x? Oh, like, okay.
This is a formula. I'll tell you how to solve it. This is a formula. Okay. These are all some elementary standard integrals.
The last year they didn't teach integrals, ma'am. Only this year it's a new chapter, right?
Yes. Okay. For example, in case you're having like 2 raised to the power x dx.
So then they'll teach from beginning.
Yeah. In case if you're having like 2 raised to the power x dx, the base a is nothing but 2 and the power x is x. So you will write your answer as like 2 power x upon log 2 plus c. And of course, you have to check this condition. And yes, a is greater than 0 because you have 2 and a is not equal to 1. Yes, because a is 2 here. So you're allowed to use this formula.
Okay, 1 second.
And you do have, okay, you just note down this. We'll do one more question.
Okay. Okay.
Okay, in your textbook, you do have a second question, which is 5 power x. Can you integrate that?
Yeah.
Okay.
You want me to read it?
I want you to do it.
Yeah, I'm doing that. What is e to the power x dx? Same like that?
It's e power x only. No. You just do the 5 power x alone. E power x, I'll teach you.
Yeah, I did 5 power x. So log answer is 5 power x by log 5 plus c.
Yeah.
So e power ex will be 7x. So it will be 7x plus ex divided by log 7 plus log e, correct?
No, not e.
Wrong.
No, it's not applicable to e. E is different. See, e is a constant. You do have a constant value for e. What is e?
E is 1 by log.
Okay, you have some numerical values to the e. What is it?
Oh, I forgot 1 point something, right?
It's 2.7 something.
2 point?
2.7. It goes on like 2.712 like that.
E is equal to 2.7, correct? 2.7. Okay.
2.71828183. Like you can remember like 82, 81, 83. After 2.71, like 82, 81, 83 like that.
82, 28. Okay.
Yeah, that is E. Okay. So integration of e power x dx is e power x only, but there is a formula like you have e power ax dx is equal to 1 upon a e power ax plus c. This is the appropriate one. This is the appropriate one because here you have a question which is e power x dx. The answer is e power x plus c. But sometimes they will ask you to solve what is e power 2x. Okay. This a is nothing but the coefficient of x here. So you have to write the coefficient in the fraction form like 1 upon 2 and then you have to write it like e power 2x plus c.
E to the power ax dx is equal to 1 by 8 into e to the power ax plus c. Okay.
You do have a theorem for each and every derivation, Shreynik, but you don't have to spend time on learning that.
I know.
Like if you find time, if you find enough time to go through all of them, I'll send you the video links. Even I have made several videos on theorem and all that. You can take a look at it if time permits you. Otherwise, you just by heart like assume this as some standard function or some identity and by heart it.
Okay. Okay. Okay, so
it's
I'll
like,
do some.
They'll use Taylor series and all that. It is very interesting, but it will take time. Like if you are in pure mathematics, then it would be very easy for you to understand all the theorems and all that. For applied mathematics, you don't have to learn all those. Like they will use Taylor series. Have you ever heard Taylor series? I'll just show you one. I'll show you one. For example, there is a Taylor series expansion for e power x. Okay, e power x can be otherwise written as 1 plus x upon 1 factorial plus x square upon 2 factorial plus x cube upon 3 factorial. It goes on like this. This is the expansion of e power x. Okay, this is Taylor series expansion. I think my internet connection is unstable. This is Taylor series expansion, which means like you can write like 5 as 1 plus 1 plus 1 plus 2, right? This is also 5.
Okay,
so this is equivalent form of e power x. Okay, there is a Taylor series expansion for e power x.
E is infinity.
E is not infinity. I just told you. E is 2.71828183.
2.7.
Yeah. Okay. So now if you're having like e power ax, no, you will just rewrite each and every x into ax. Okay. So you will be getting the answer like 1 plus ax. I'll just show you one proof. Okay. Ax upon 1 factorial plus you have x square here, which means you have to square them. So you need to square a also and x square also upon 2 factorial. You have x cube here, so you have to cube the a and also the x as well as the x. So it goes like that. And then the next term would be a power 4 and x power 4 upon 4 factorial. It goes like this.
Correct.
Okay.
Okay. Okay. Got it. But the sum is different now. It shows 7.
This is not a sum. This I'm just telling you, like you do.
No,
have
I know the theorem. I know.
The theorem
But the sum is. Yeah, I understood the theorem, but the sum, second one is different. 7 to the power x into e to the power x.
7 to the power x into e to the power x. That is different. I'll solve it. I'll solve it. I'll tell you how to do it.
Okay.
Please note it down. Note down this.
Yeah.
So in our integration, we were integrating this, right, shreynik? Like we were actually performing integration of this
Yes,
e power ax, right? So you need to integrate this entire Taylor series. Okay. If you integrate, like what is one integration of 1 with respect to x, shreynik? How will you rewrite x 1 in terms of x? I'm asking only about this. How will you rewrite x to the power 0? So what if you what you will get if you integrate this x power 0?
X to the power 1 by 1.
X to the power 1. Which is x.
Yes.
Right.
Yes.
So the answer for the 1 is x. And what about this? This a and 1 factorial are constant, right? And you do have x here. So what about the integration of x? It's x power 2 by 2, isn't it?
How? Yes, x power 2 by 2. Yes.
So integration of x is nothing but because it is x power 1, so you'll be getting x power 1 plus 1 upon 1 plus 1 according to this x power n plus 1 upon n plus 1 formula. So you'll be having x power 2 by 2. So this will turn into, this x will turn into x power 2 by 2 after the integration. Here you do have 1 factorial. 1 factorial into 2 is nothing but 2 factorial. Okay. So you will be having a into x power 2 divided by 2 factorial. This a is nothing but the constant. I have already told you when you perform integration, if you are having any constant in the form of an multiplication or division, you just have to keep the constant as it is. Okay. So just keep the a as it is. Do not disturb them. You integrated x turned into x square divided by 2, and you do have 1 factorial in the denominator. 1 factorial times 2 will give you the result as 2 factorial. Clear?
Correct.
Clear?
Yeah.
Okay.
Yes.
So now I want you to answer the second one. Okay. So can you answer this?
Okay. So it will be a square into.
It will be a square. You cannot disturb a square. Very good.
Into x cube.
X cube.
Into x cube by 3 factorial.
3 and you have 2 already, right? So you will be writing it as 3 into 2 factorial.
Oh, 3 into 2 factorial. Oh,
5,
6 factorial.
You just write it as 3 into 2 factorial itself. Okay. We will be taking some common term out. Okay. Do not multiply them. Okay. Just keep it as 3 times of 2 factorial itself.
Okay.
And then like this will turn into, like you will keep a cube as a cube itself. And this x power 3 will turn into x power 4 upon 4. And you do have 3 factorial already. Just write the 3 factorial also as it is. Understood? And after the integration, we do include this constant plus C after that. Please note it down.
Noted.
Okay. So now what I'm going to do, I'm going to multiply the entire thing by A, and I'm going to divide it by A. I'm going to divide the entire series. I'm multiplying this by A and dividing it by A. Note down this as the second step. Again, you write the same step. You write it as like multiply and
Mom,
divide it by.
Mom, I
A.
can't hear you. Hello, Ma.
You can't hear me. Okay, what I was saying, I'm multiplying this entire series by A and dividing it by A. Hello. What happened? Can you hear me, Shreynik? Hello.
Voice is breaking.
My
Yes,
voice
now I
is
can.
breaking. Okay.
Yeah, now it's fine.
Okay. What I was saying, I want you to multiply the entire series by A and divide it by A.
Why? Okay.
I'll tell you why.
Okay, so 1 by A.
You just multiply them by A and divide it by A.
Yeah, so I did it. So after A, so it'll be.
Now you
Hello?
take the A alone inside and multiply them. Okay, I'm erasing this Taylor series.
So it'll be ax plus a square x square plus a cube x cube, correct?
Yeah, just a second. Yes, you are right. So 1 by A into ax plus a square x square upon 2 factorial plus a cube x cube upon 3 times of 2 factorial plus a raised to the power 4 x power 4 by 4 into 3 factorial. So now you will be able to notice a similar power over here and here. You're getting straining. That is why you're taking the A inside and you're performing multiplication.
Oh.
Okay. Please note it down.
Noted. Yeah.
And that C also will become AC. This C also.
Yes.
And it is not compulsory to write AC. It's okay if you put only C alone. Okay.
Okay.
It is not a big deal. Like just
okay.
AC is also a constant only. You can rewrite them as a capital C itself. That's fine.
Okay.
Just let me remove this bracket. Let me remove this bracket. Like you will have it like you'll be having it like plus and so on. At last we'll be having C, right? So when you multiply this by A, it became AC. Okay. I just want you to rewrite this now. Like rewrite in the sense. Let AC is equal to C plus 1. Substitute AC as C plus 1.
Yes. Let AC is equal to C plus 1. Why are we doing that?
I'll tell you why.
Okay. Let AC is okay.
Just a minute. Okay. I'll tell you why. So C plus 1 is nothing but, okay, let me include that in the series first. It's 1 by A plus AX plus A square, x square upon 2 factorial, A cube x cube upon 3 times of 2 factorial plus and so on, AC. I've rewritten this AC as C plus 1. You just switch the position now, Shreynik. You just move this 1 here because addition is commutative, right? 1 plus 2 can be written as 2 plus 1. Okay. So I'm just switching it. I'm writing it like, I'm taking the 1 over here and write the remaining stuffs like AX plus A square x square upon 2 factorial and A cube x cube upon 3 times of 2 factorial plus and so on. And you have C here plus C. Because now you will be able to see an order. 1 can be written as A power 0 x power 0, isn't it, Shreynik?
Yes.
Anything power 0 is 1. A power 0 is 1 and x power 0 is also 1. 1 into 1 is 1 only. So now if you look at the series, like the series is, the power of the series is getting increased. Like AX means A power 1 x power 1. And then you do have A power 2 x power 2. And then you do have A power 3 x power 3. You'll be able to notice an order. Yes?
Oh, 1 second, but I'm not. 1 second. Okay. I'm not able to understand only this. This part I didn't understand. Only one part. Wait,
Okay. What I was saying that we are rewriting AC as C plus 1. This you understood?
Yeah, AC as C plus 1 I understood.
C plus 1 you have understood. And then what I was saying, addition is commutative, right? Like 1 plus 2 can be written as 2 plus 1 also. You can switch their position.
Yeah.
Right? So by that way, I just switched this 1 to here. I just drag this 1 to this position. You're getting it? That's what I did in the next step. Because it is commutative. Okay. Addition is commutative. That is why I've taken 1 over there.
Okay.
Now you would be able to see an order. What is 1? 1 is nothing but A power 0, x power 0. And AX is nothing but A power 1, x power 1. And you have A power 2, x power 2.
No, this only how? Yeah, ma'am. See, till I wrote till this. How did this come? A to the power x.
You have A power x already.
Oh, then I didn't write then. Why did I not write? A power x,
you have missed it. You do have A power x already.
Oh, okay. Oh, yeah, we have. Oh, yes. But no, ma'am. A to the power x, we already made it by integration a into x square, we made it, no, ma'am.
No. Like we have changed the 1 as x power 0. And then when you integrate this x power 0, it became x power 0 plus 1 upon 0 plus 1, which is turned into x power 1 by 1. And then we finally got our x term. And that x is here. And we multiplied the entire series by A and we divided, right?
Yeah.
And that is how this x changed into AX. Understood?
Okay. Yeah. Okay, ma'am.
Okay. Please let me know if you didn't understand. I'll explain from the beginning.
Understood.
Okay.
I understand.
So now you're having this series training. So now if you compare this to the Taylor series again, you have a standard Taylor series, which is e power x is equal to 1 plus x by 1 factorial and x power 2 by 2 factorial plus x power 3 by 3 factorial, right? And e power ax is nothing but 1 plus x upon 1 factorial is nothing but ax by 1 factorial plus x square by 2 factorial means it will be a square x square by 2 factorial, and you will rewrite x cube into a cube x cube by 3 factorial, because you're just replacing the x as ax. Are you able to follow it? So now this looks like e power ax. I'm changing this entire term. Apart from 1 upon a, I'm changing this thing into e power ax again. At last you have plus c. That's it. So that is how they derived integration of e power ax dx as 1 upon a into e power ax plus c. Understood, Shreynik?
Okay.
Understood. So that is why I was saying, like, learning the theoretical, explanation for each and every formula will take time. Instead of digging at the explanation, for time's sake, you just by heart it now. Like, when time allows you, you can refer all of it.
Okay.
That is why I just explained only one thing, so that you can, like the a power x also, you will be having some similar kind of explanation only. You'll be able to understand by yourself if you refer them.
Yeah.
So here they just used Taylor series. I have already told you integration is otherwise known as like summation only. In Taylor series also, we didn't perform any integration. Like you had like many terms which put together in the form of summation, right? So they did the summation only, but somehow we got the answer, which is 1 upon a into e power ax plus c. So that is how they derived.
Okay.
Okay, I'm not going to explain any formula for today's session. We will solve the problems alone. Okay.
Okay.
Okay. Okay. Are you noted down?
Yeah.
Shall I erase it?
Yeah.
Okay. So the formula for integration of e power ax dx is 1 upon a e power ax plus c. Okay. So integration of x dx means nothing but here you do have 1, right? 1 into x is also x only. So it will be 1 by 1 e power 1x plus c. 1 by 1 is 1 only. You don't have to mention that. E power 1x plus c. E power 1x also you don't have to mention e power x plus c. That is why integration of e power x is e power x. Understood, Shreynik?
Yeah.
Okay.
So this sum we can do it like, we should just change the order. We should make it e power x 7 power x, like that. Correct?
Sorry, we should make it like
e power x 7 power x dx, like that, no ma'am? Because the formula is like,
what is the question?
No, nothing.
In case if you're having like integration of e power 7x dx, then a is 7,
no.
So it's 1 by 7 e power 7x plus
no,
c.
ma'am, it's not like that. It's not like that. It is 7 power x e power x dx.
No. For 7 power x, you cannot use this formula. For 7 power x dx, you have to use a power x formula. 7 is the constant, right? 7 is 7.
Yeah, 7 is 7.
7 cannot be e because e is 2.71, right?
Okay.
How can you compare 2.71 to 7?
That's it. Yeah.
You're getting it?
Yeah.
So you have to use a power x formula for that.
A power x, okay. What is the formula, ma'am?
You just told me. A power x by log a. We just did.
Oh, a power x by log a. Oh, okay.
You solved the 5 power x one, right? Do you remember?
Yeah. So it will be like is equal to what is the formula? I forgot. Oh god. Oh, yeah. So it'll be 7 power.
No. You just solve this. I'll give you a similar question. You can do the a power x afterwards.
7 to the power x log 7 by log 7, correct?
Yeah.
And how to do e power x? Same. E power
For
x
e
by
power x, I just told you this formula. For e power x,
E-
this is your formula.
oh, like that we should. Yeah, I understand, but we should. Okay, okay.
For e
Oh,
power x, it is
one.
a separate formula, Shreynik. Do not confuse a power x with e power x. A power x is different. E
Then
power
how
x
do
is
I write?
different.
Then how do, ma'am? Can I show on screen? Can I write on screen 1 second?
Yeah, you can.
So it will be like, how will it be? So of e power x, correct?
Yeah,
Will
that's your
be
question.
yeah.
Put dx.
No,
Put dx.
I don't understand. Ex.
What's your doubt, Shreynik? Like you have to write it along with the sign. Like you have to write
Okay, ma'am.
dx here.
Let me do one thing. I'll do the whole question in this. I don't understand this. Wait 1 second.
See, you
question.
don't understand means you ask me. Just a second. I'll just solve both at the same time. You please wait. Can you
Okay.
erase your screen?
Okay.
I'm not able to do
Yeah.
it. Can you erase it, please? I'll
Yes.
solve both. You are getting
Okay.
confused with e power x and a power x. Both are different.
Yeah, that's it. Yeah,
Okay.
yeah. Okay.
Integral a power x dx is
Integral a power x dx is okay.
just
Which
a
is
second. What is integral
a
a
to the
power x
power
dx?
a power
Okay, I'll
x
tell you
divided
one
by log
thing.
a.
There is a elementary standard integral in the page number 242.
240 where?
Page number 242. You refer that. There you'll be able to see this formula. It's a power x upon log a plus c.
Yeah, log a plus c. I got
And a
this.
should
Yeah, I
be
got
greater than 0 and a shouldn't be 1. Okay, this is the condition.
Okay.
So in case
This
if
I
you're
got.
having like 5 power x,
X. Yeah.
the
So
value of a is 5 here. Okay.
yeah.
So it will
So it'll be
be
5 power x.
5 power x upon
Why log 5? This I know.
log
5
5.
plus c.
Okay.
Yeah, this I
For
understand.
e power ax, it is different. For e power ax dx, it is a different thing. It's 1 upon a e power ax
X.
plus c. Okay. So if you are having a question like e power 5x dx, then the value of a is 5. Okay. So it's 1 upon 5 into
5.
e power 5x plus c.
Yeah,
Understood,
okay.
Shani?
Yeah, understood. Okay, but now the question is, ma'am, in 7.1 second, what is the question? You know that, no? Can you see the question?
In 7.1?
Second one, second subdivision. See that question, ma'am.
Okay, second one, second subdivision. You do have 7 power x into e power x.
That's what I was trying to tell you. Yeah.
Okay. Okay.
This
Please
I
wait.
got this.
Okay, please wait. I'll tell you how to do it.
Okay.
So 7 power x into e power x, right? This is your question. But over here, you do have similar power, right? You do have similar power. So we can rewrite them into 7 into e the whole power x dx. Can we do that?
7 to wait. How again? Again, can you do? Wait. 7.
You
How can we do that?
you have x as the power to 7. X as the power to a. Both shares the common variable. Can
Same
I
power.
club
Oh,
them?
yeah.
Can I
Yeah, we
club them?
can.
Like 7 into e the
Yeah,
whole
club them.
power
Correct.
x, isn't it?
Yeah, correct.
So now this looks like integral a power x into dx. Why it is a? Why I didn't go for e? Because it is 7 into 2.7 something. You will be having some value which is around 15. Okay.
Okay.
You're getting it?
Okay.
15 or 16,
yeah.
something like that. Okay. So that is constant. That number is constant. So that is why we are using this a power x into dx formula. So the answer to this a power x dx is a power x upon log a plus c. Right? So a power x means here I'm assuming the 7e as a. Right?
Okay. 7.
So
okay.
It will be 7 into e power x upon log of a. What is my a? It's 7e, isn't it? Plus c. That's it.
Oh.
Understood, Shrenik?
Yeah, understood this. That's it. Okay. 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 So third one will be
What is the third one? It's 4 power x upon 9 power x. This also, like this question also, they share the common power, right?
yeah.
You just write this as 4 upon 9 the whole power x dx. Okay. What is 4 by 9? You'll be getting some number value. Okay. Definitely that is not 2.71 or something. Now 4 by 9 is a constant. So which is a. I'm just assuming this is a. Okay.
Yeah. So
again,
it'll be
integral a power
4
x
by
dx
9.
is nothing but a
4
power
by
x
9 to the
upon
power x
log
log
a plus c. So first write what is a. A is 4 by 9.
4 by 9.
And x is x here. That's it. So you have that clarity first. So the answer is a power x, which is 4 by 9 the whole power x
to the power
whole
x
divided by log a. What is your log a? It's 4 upon
4 by 9.
9.
9 plus
C. Understood, Shreynik?
Understood. Yes, understood. Understood. Hello.
Yeah.
Yeah, understood. Finished also.
Okay. Okay, Shrenik, what do you do? I'll give you some homework questions. Okay, do it without fail. The illustrative examples. Okay, from the page number 242 and 243, you try to solve the example 1 and 2, all the subdivision. Example 1 and
second.
example 2, all the subdivision. Please note it down.
1 and 2. Okay.
Yeah.
Okay. Okay, done. But example 2 is all loggy and all, no, ma'am. Oh.
Sorry?
Okay, I'll do it.
No, you ask me. Don't hesitate. Tell me, what is it?
No, but example 2, it's all log e.
Log e. What do you mean by log e? What is e
by
power log e? What is e raised to the power log?
e?
What is it? It's 1.
Oh. Okay.
You only told me e is the reciprocal of log. You know that.
Yeah.
Right? E raised to the power log is 1.
Okay, so
you can directly cancel it out. Like before integration, like before performing the integration, you can directly make the cancellation out of this by using this formula. And your question will be root x upon x. That's it. And then still you can simplify the question. Like the question is root x upon x. You just rewrite this x into root x into root x. Okay. Cancel out the root x in the numerator and the root x in the denominator, and you'll be left with the root x in the denominator alone. So you just write them in the form of a power, which is x raised to the 1 by 2. And then you just take this to the numerator and solve it by using the x raised to the power n formula. Understood, Shrenik?
Okay. Yeah, understood. I'll do it.
All right.
Thank you.
Okay. Do you have any doubt in today's session?
No, ma'am.
Okay, I'll just quickly tell you what and all we have discussed in today's session. We discussed 3 things. One is integral x raised to the power n, and another one is integration of e power ax, and then integration of a power x. This a is nothing but constant. You take any integer. Okay, e is nothing but 2.71828183. 2.7 if you simplify this, if you take an approximation out of it. Okay.
Okay.
I hope it is clear. We'll see on Tuesday. Okay.
Yeah.
Okay. Okay.
Okay.
We can take leave.
Thank you.
Thank you.
Thank you.